Purpose of this video is just a really quick overview of standing wave mathematics. This is a standing wave. You may or may not have already done something that looked kind of like this, but it's important to note this standing wave right here has this is called the nodes are down here, and then this is the antinode is here, and this would be one that is in the first harmonic. If you change the frequency, here we have it, and now it is in the second harmonic. Second harmonic, and again, this is a node, this is a node, this is a node, and then these are antinodes. And this would be in the second harmonic. Now,
103.
Here's one that is in the third harmonic. So this would be the third harmonic. Whoa, third harmonic. 1, 2, 3, and we have nodes here, 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 and here, and then of course 3 antinodes. Now, the wavelength of a wave is, I tend to say just 2 loops, but it's basically every other time it crosses, so this would be basically 1 wave there. So the wavelength is basically 2 loops, or every other node, if you will. But we have a couple of equations that talk about which harmonic are you in, which harmonic are you in. This one would be 3, and then this would be an example of a closed. There's a couple other things it could be. You can have what is known as an open-ended pipe or a closed-ended pipe. So the previous examples I showed you with string, and that was closed. It is also possible to get standing waves that form due to sound is typically where we see this. But and you can think of it as open end, so this is open and then this is open, or this is closed and then this is open. And I have some more longer videos to show more about this, but this is just a really quick overview. And it's important to note that each of these on the closed pipe, the first harmonic, so these would both be the first harmonics here, and then this would be the second harmonic, and then this would be the third harmonic. And effectively, if you look at this a quarter of a wave, what you would see, we'll change colors here, like this one, a quarter of a wave. What you're actually seeing is effectively this part of a wave right there. Or over here, what you're seeing is basically this part of the wave right there. So we have some equations to tell you what is the wavelength, for these waves, and what is the wavelength for these waves, and it all has to do with this distance here being L, and then what is the wavelength associated with that. So over here, if a standing wave is closed or fixed and open on one end, then your equation is the wavelength equals 4L divided by the number of harmonics. Note, this should be an odd number. And then on the flip side, the other one is
101, 101.
Flip side, the other one is, sorry, wrong one, there we go. If it's closed in, fixed in, and then closed in, closed, fixed in, closed, closed, basically, or open, open, or loose, loose, wavelength is equal to 2L times the number of harmonics. Hopefully you pause that and get that in your notes, and this should help you get where you're going. There's another longer video posted, but this is a good start. Thank you, and make sure to have a great day.